All right, thank you, Joe. And my name is Andrew. I'm president of Evezor Robotics, and this is a project that I've been working on for a while. It is Floe. It's a Floe-based programming application. So it's an IDE to write different programs for various things. The things that it's really geared for is distributed compute, or whatever you want to call it, distributed systems. So when you're building robots and everything like that, you oftentimes have things that might be spread out very far. When you're dealing with electronics and whatnot, it is difficult to have things all work together. You either have complexity in wiring or complexity in a lot of your code, and the code really could be boiled down to you just kind of have net lists. So somewhere you have like some spaghetti and you need to try and rectify that. So without any further ado, let's just get started, and we will just start writing ourselves a little program here. So I will just create a new canvas. And so this is where we are going to draw a new program. Live demos are great. I don't know what's going on with my internet connection here.
Was it able to get outside or?
Seems like my browser must just be freaking out. Can I restart my browser without it killing everything?
You did load into the local network here, right?
Well, I'm on my phone if I want to talk to this thing.
Oh, I see.
So I guess I can just jump off. I think it'll be okay. Sorry, guys. Hopefully it'll just let me right back. Okay, so here we are, and we've got a blank canvas. And have any of you guys ever used Node-RED? Okay. So all your flow-based programming is kind of the same idea here. You're going to have some kind of elements that you're going to drag onto the canvas. These elements are like objects like you'd have in Python. So I can try and make this a little bigger if that helps. And at any point, I'm still developing all this. So if you see something, if there's some design pattern that you're aware of that I'm not, or something that you think is interesting or fun, just please ask a question at any point. So we have dropped a new element on here. Let's just give it a new name here. We'll just do CK so that as we'll do CK1. And let's go ahead and run this. So one of the cool things here is we can run these with PyScript. Oh, come on. I think I forgot to save it. So we dragged on a GUI checkbox, and you can see now that a checkbox is here on our program. And let's go ahead and kind of put these side by side so we can keep making some changes. So you can see here, there's a whole bunch of stuff on this screen. So you can see here that we've dragged a checkbox on there, and we have a checkbox in our program over here. We can go ahead and check. Let's go ahead and grab another one. And now the way that you work with these is you connect them together. So basically when an event happens on checkbox 1, we're going to go ahead and send it into checkbox 2. And let's go ahead and give that guy a name as well. So now we have 2. Let's go ahead and save it. And we will go over here and we'll refresh this. And now you can see here that we have 2 checkboxes. And I guess one thing that I should note is over on the right-hand side of the browser here, we are actually running Python. This is PyScript that's running in the browser. So what we have on the left is compiling, and we're running it on the right. Again, we have 2 checkboxes here. You can do whatever you want with checkbox 2, but as soon as you hit checkbox 1, it's going to send the message from checkbox 1 to checkbox 2. So some of the other cool things that we have here is we've got a REPL prompt up here. So you can see here that we have our checkboxes. We have checkbox 1. And you can also pass it stuff just like an object. So again, this is Python here. So we can just send it to true. And you can see that now it has checked it and also sent the message to checkbox 2. And we have a little program already here running in a few minutes. So again, just real quick, we can add a couple other things on here. Let's do a slider. We can have a slider go into a slider. Again, a lot of these seem kind of simple, and that's kind of the idea behind some of this. We have some float elements, and again, as we keep adding these things, we are just going to automatically be getting them over on the program. So go over here, we'll refresh.
Didn't do a save.
I'm sorry?
You need to save.
I did save. So you can see here now that we have all of our elements. Again, we've got a slider here. You can slide it around. But as you go and slide around the next one, then this one will follow. Same thing with the other elements. And I guess one other thing that we can do real quick here is you can see that as we go to drag around, you can see that the bubbles here will expand, basically kind of giving you some kind of like typing helpers. So you can really only connect together things that are like. I'm still working on a few of them, so let's just call this one on here and it'll follow the slider. And now you can see here that these both now will be following our slider. So to get into the nitty gritty of some of this, you can make boxes of all different kind of types of things. So let's go ahead and take a look at this slider here. Again, it's all Python under the hood. So inside of this box, if you will, we have this object. Can you guys all read that? And actually, why don't we, if there's a way to move the bar on the top for Zoom.
You just drag it.
Oh, yeah. So let's go ahead and find our slider, and you can kind of see like how these are built. So again, all these, there's Python running under the hood, and I'm working to make some of these user interface a little bit better. But again, we have a description for each one of these blocks. You have a description. You have a way to tell it how to construct the box. that you see when you drag it out onto the canvas, and different kind of values that you can put in to configure that. Again, here's the Python code that actually makes it go. And then a few more. We have some HTML here that you can say to how it's going to present itself in the browser, and also some JavaScript that's going to help this all function on the back end when you have a web GUI. So again, if we come back here just to the program that we just made, you can see here that this thing actually compiles to Python. So this is the program that we just made. It will automatically put in all your dependencies that you need, and will also generate a bunch of objects that is the code that you're going to be running. So again, like, we're kind of putting this shiny coat on the outside to make it a little bit more applicable to I guess I don't know how I want to say that, but kind of the idea is you have some of these large things, like you have a robot. I had a robot arm a couple months ago when we gave a talk, and you'll have something like a robot arm, and it's kind of complex, but you want to add some features to it. And when you look at something, kind of like this, you can see that they're connected together, so you can kind of know that you can go ahead and mess with something and not mess with the entire robot. Tell me if I'm talking too fast or. Yeah.
How does the inputs get defined? Is that what you're on this elements?
So a couple different ways. You can see here we have these hots. So like every object that you have, every parameter is going to have an ID, which is a parameter ID. And you can see that 6359 is subscribed to 5959853. And you can see these numbers here. So you can see that checkbox 1 is going to checkbox 2. According to that subscription there. So you kind of have this like net list down here, and a lot of that doesn't really, I find that that's like the most difficult thing to read in a lot of code, is just you have like these things all over and things are calling things from other places. And also somebody who has an electrical engineering background, I can look at a schematic and kind of quickly understand what's going on there. So I hope that some of this is pretty easy for everyone to kind of look at and kind of get an understanding of what's going on here. And also keep in mind that, like, you'd say, oh, I love my Python and I want to be able to write some Python. You definitely can have any of these. So you can go ahead and write functions into one of these, and have something that is just like Python, like you normally would have. When you want to do something that is not quite inside the bounds of something that you'd want to do with boxes and lines. Boxes and lines are good for some things. Code is good for others. So you want to have both. I guess I can run through a couple of examples of some interesting ones that I have. Up at a hackerspace that I'm working at, we have a bunch of lockers, and I'm working on having a series of lights that will light up lockers based on who owns them or rents them. And you can scan your RFID and basically rent or buy a locker there, and it will kind of keep time and address all the things with handling assets or something like storage. So let's go ahead and we can run this one, and you can see here that we have all the lockers. If you were to scan a fob, I have a little test button here that will kind of emulate running a fob. These claim buttons kind of come up. It'll say, oh, I've gotten a message from some user, and then everything breaks. I think maybe I timed out. Oh. Did I say that it was a work in progress? Live demos. It was working just a moment ago, I swear. But one of the other things that I'd like to highlight here is the fact that this particular one here is actually the code that would be running on an ESP32. So on the ESP32s, you can have a version of Python called MicroPython. And so kind of one of the nice things here is you can create your program in here and debug it in your computer, and then you can go ahead and flash it to your devices. Knowing that some of your functions will work. It's easier to develop just in the browser and all that before you go ahead and push it down to your other devices. Again, to move on from the last talk that I gave about different ways to like make a robot go, and you can throw in some G code here. Since that talk, I've learned that there's something called JSON lines. Has anybody ever heard of that? Okay.
Use it a lot to like test data, machine learning data sets.
Yeah. So
It's JSON object of lines.
correct. Yes. So it's basically like a giant JSON list, sort of, but everything is just separated with new line characters. But anyways, so again, you can kind of run Python anywhere. These things can be running on your robot. They can run here. They can run in the browser. And this particular one, we would have a couple of 3D viewer objects. I suppose we can go ahead and take a look at this real quick if you'd like. But you can see here that we have a few elements that will automatically be generated. You can go ahead and change some things here. So let's go ahead and change this. And so basically, we will be rotating this. So let me go ahead and hit the submit button on this guy. It'll take a second to calculate. I think it went. I should have done a bigger number. But anyways, yeah.
So like when you bundle it up, like how does it take the code that we saw generate?
Mhm.
That's what gets shipped over, and then plus any libraries and other things that get shipped.
Yeah, so it depends on where you're running it. When you're running it, I guess I can show this. We can just view source. So you can see here, we just have a bunch of kind of setup stuff. And then we get down here, and here is where you can see we are pulling in all of our different libraries. So on the back end, it's going to go ahead and give it a list of requirements that need to be added on. It will add them in here. And then again, we have PyScript. So basically the whole Python program is going to be, we have the 3D viewer, so this gets a little bit bloated. Here's all the HTML and JavaScript also gets added in there for any of the elements that require any of those. And then when we get down here, you'll see, well, this doesn't actually have very much. Where is it? Oh, actually, I think I've changed it now. Everything kind of gets bundled away, and you're importing this config directly. Let's see. Yeah, so the Python executable that we saw is actually just imported in here. I don't know if it's that easy to see. I believe. So when you do this, it should come up with everything, and yeah, So there is a file system kind of built in to Python in the browser in PyScript, and kind of I'm trying to expose everything. One of the things I love the most about Python is introspection. So you should be able to kind of like look somewhere and find out why something or what made something come from somewhere. Again, this one's a little bloated because it has a bunch of code over here. But again, this is the program that you see that is running the 3D viewer that we saw over in the other window. And then we can move up. So let's go ahead and go back home here. I have this little demo here. I think we can kind of wrap some things up, but you can see here that I've got a little remote and we have linked some things together. And so that program is going to be here. So again, the canvases that we saw for each one of these little ones, I think we're getting pretty close on time. Is that right? So we have this stacklight board, which is going to be this one here. And you can see that the joypad here. And real quick, I guess we can go ahead and open up one of these. So the program that's actually running on here is going to be this one. And there isn't really very much exciting going on in this one because it's just a bunch of buttons. But what comes out of this one will actually go up to here. And now you can take red button and go directly to red on the light. And the same thing with some of the other colors. Blue is the buzzer. And so you can quickly create and modify and debug these. I guess if I was still on the same network as this thing, one of the other nice things, because everything is all in one place on this canvas, if I were to actually go to the REPL prompt, like you saw in some of the other ones here, you would actually be able to call up stacklightboard and say stacklightboard.red, and then give it like a true or a false to turn it on or off. And actually so all of the, I have way too many tabs. So all of the objects that you see here are available to be used as if they were like part of the board that you're using as your portal to get like onto the network. And again, these are all networked over CAN bus. Yes.
Can you embed like this diagram, have some inputs and outputs for it so that it becomes one block in a higher level?
Yeah, I'm afraid to keep like moving that far because every time that you move up one of these levels, you have different types of complexity that you end up with. The one that I'm kind of more interested right now is the one that goes down from, so down from one level, we're at the board level, and I want to go down one more level from that. So again, like I think at the end, you're kind of going to have just like stacks of these things. What you end up building is just like a directed acyclic graph. And so this ends up being some kind of n-dimensional acyclic graph, which is kind of hard for your brain to handle all at once, which is why I think that this tool hopefully will be nice to help people sort of grapple with all that. Any questions?
You get the cool little stack light.
China, where all the things come from. So the stack light itself, of course, I ordered somewhere else. As far as all the boards that you see here, these were all made by me. So all the circuit boards, and then actually one of the robots that I built from these pieces is my pick and place machine that puts together these boards.
Can we use this?
Yeah, floe.ebuzzard.com. There was a question back there.
Did you use an existing like box and line canvas platform, or did you do this from scratch?
I did. There's a really nice, it's called Draw 2D. And I think the guy that originally created this thing created it to have some sort of in the browser schematic editor, more geared towards like circuit design and that. And then I kind of co-opted it into the thing that you see here.
Is that way through like version control?
That is something that I really want to have. I have not implemented that yet, which is why you'll see some of these things kind of like appended with like suitcase, because like that's the project that this particular one was like embedded in. There's kind of a thing that I'm trying to grapple with in my head. You have like this stack light that's here. There's just some generic one over there, and they might be the same, but like the context in which they're operating in is different. So how do you like define some of these contexts? And I know that didn't answer your question directly, but it's kind of in the same vein. It's like we have two things, but they're different. So we have two different versions of the same thing, and then version control on top of that one. So the answer is yes, but it's a little bit more complex than I've had time to just meditate on and kind of figure out how to present it in a way that's easy to understand. Anything else? Yeah.
You're using PyScript. Are all the calculations made on the client side?
I'm sorry, can you say the question more?
Are the calculations made on the client side, like in the browser?
No. Most of the time, the answer is no. Because you can kind of think of it like anything that is Python can kind of be run Python anywhere. So you can kind of think of it, even though it's just in the browser, Python is still like the back end, like it's some server somewhere. And that's typically going to do the computation. There is sort of a trick of the mind here or something, which is when you know that you're going to be running on an embedded device, your client-side device is orders of magnitude more powerful than the device that's actually the server. So again, like if I can kind of find one of these here, it's like, where do you want to lay the complexity? Typically, I like to just put all the complexity into Python. And that's definitely the only place where any object or parameter will talk to any other parameter is actually only on the server side. But if you wanted to do some client side pre-processing or something like that, that's definitely doable as well.
Okay.
Yeah.
Along that line, it's like which code runs on the client versus the server? Like obviously this stuff is on the client.
Well, again, it gets difficult when we're running PyScript because people like to just like lump it all together. So like let's act like we're just running it on one of these boards over here. Basically, we've got some markdown here and this constructor item here. And these ones basically are only there to let Floe decide how to construct these boxes. And if you were to do any of these, you can see that like we have this checkbox and it kind of has some markdown in here. So how all of these checkboxes and options and everything are all constructed is all in this JSON constructor thing here. So these are all basically Floe only kind of things. Python here, this is what's going to be running actually on the board or on the server or kind of like on the Python backend when you're running something in a browser. And then this HTML kind of just gets jacked into this kind of object here, which is just going to be on the browser side. So this is like client side for JS and HTML, server side for Python, and then Floe for these first two. I know it seems like a lot, but is everyone else kind of fans of domain-specific languages? I know it's a lot to like kind of bite off, but different languages do things a little bit better.
Only if it makes me avoid writing JavaScript.
Yeah, that's kind of a necessary evil with some of this stuff. Usually it's not very much, so. Yes.
So this seems to be mostly data flow driven as far as sort of your compute model.
Mhm.
And you also seem to support fan out of multiple outputs. Do you have any constructs for being more explicit around parallelism and joining?
Parallel, well, everything runs in parallel that's not, connected together. So like, these slider elements and everything.
More explicit parallelism or sequencing if you care about it. Like particularly if you're doing hardware,
Mhm.
things might be parallel, but you might also have like sequence points that you want to enforce. Do you have sort of sequencing and join constructs?
Yeah, that's something that I'm exploring. I think that there's kind of a few different ways that you can model these things. And I'm going to kind of just like say there's like one way to do it, which is like kind of with Kafka, how you have your partitions and that. And so you can kind of have like one model, all your clients are kind of getting all of the messages, and then they can kind of decide whether they want to react or whatnot. Again, a lot of this is like whatever your producer is just going to be like barfing things everywhere, and your subscribers are going to decide whether or not they want to act or not. As far as what's explicitly, you do run into a lot of that when you're doing kind of some robotics things where you want to, I don't know how I want to say this, where you have events and other kind of things will start playing based on events, and you end up with this kind of giant choreography of things. And these are, yes, they're on the table. I don't know exactly how the best way to present some of these because it just starts getting very complex. They're not like easy things to do. What is idempotency? Kind of when you have some of these, that makes it easy. And kind of the way that I'm seeing it, I'm hoping that there can be some kind of blocks that are kind of like designed to help you get a lot of the heavy lifting done without actually kind of having to write a lot of these things yourself. Does that answer your question?
Yeah.
Okay. Anything else? Yes.
You mentioned Node-RED before.
Yes.
What inspired you to do this that wasn't able to do, I guess?
Well, okay. So first off, Node-RED is JavaScript. So gross. For two, it kind of seems like Node-RED. I don't want to use the word like, the thing that I like most kind of about Python is, well, at least previously, we'll see if this continues in the future, is like purity of vision. So there's kind of a Pythonic way of doing things. And when you get over into something like Node-RED, it's just very messy to me. And there aren't really very many like clean ways that things kind of connect together. Like we had the question about like, how do you like have these choreographies going, and like some of those are even less defined in something like Node-RED. So I don't really want to like harp on it too much. So it's partially, I've seen things like Node-RED, and partially also my electrical engineering background, schematics, and like a lot of this basically is just like net lists, and you're basically like creating net lists. How much of programming is actually like writing a bunch of like boilerplate crap and then connecting them together is like actually what your real program actually is. So like, can we have something in a way that like sort of exemplifies that portion of it rather than just looking at creating kind of fancy looking net lists and whatever. Airflow is one of those ones where I look at it and I'm like, okay. Anything else?
I know you have more of the background, but I have played more with CircuitPython or Adafruit, but it's more like particular and tailored, so less flexibility, I feel. Do you have like any resources that you found helpful?
I'm sorry, can you say the question more?
Like any resources that you recommend learning MicroPython? I have played with CircuitPython, which I know is like way easier, but
Yeah. My problem with CircuitPython is they seem to have like changed their API a whole bunch of times, and so you have a whole bunch of things that aren't relevant anymore. But this is sort of a broader thing. It's like, well, I want to learn programming in general. What do I start with? A, find something fun. B, probably there are a bunch of I would just say find some libraries and components that you think are fun, and then something that you want to build around that, and then build it. Especially somebody who has some kind of already coding background, interfacing with hardware. If that's really your only sort of like roadblock there, that one should be able to be overcome fairly easily. Is that all? Oh, one more.
What's the most silly or fun project you've made using this platform so far?
The most fun?
Yeah.
Well, I got a robotic arm that I did, and it's played checkers and draw pictures and all kinds of that stuff. So that's kind of fun. Actually, the last time we were here at Slalom, I didn't bring in this demo, but I have a escape room in a suitcase sort of demo. So I can actually pull up that program here. So this is an example of some of them can kind of get to be a little bit complex. So we've got a screen like this guy, and it will kind of give you some instructions, and then it's got some little fans and patch panel and all kinds of different things. And you're kind of stair-stepping through the game. So let's go ahead and take a look at this one. We got the screen on this one that pretty much kind of runs the whole game logic. So let's see if I can kind of fit a bunch of it on the screen here. So I don't know exactly the best way to kind of like give some tools to make it easy when you look at a screen like this to see what's going on. But like kind of we have a as we go through our game, we kind of like unlock different sort of game. The way all the hardware is going to behave is different based on the level that you're at in the game. And these are kind of just like defined with a little bit of blocks here on like what's going to be on the screen, and then sends out some messages saying, okay, we're on patch panel game, and kind of like all the hardware will reconfigure itself to be based on patch panel. And I guess that kind of answers some of your question there. It's like, how do we kind of do these? And we sort of have, in this case, like a ringleader that's like telling everybody, it's like, hey, we're in this game state now. And they all kind of pick up that message and do that. Again, this stuff does get kind of just complex based by the nature of having things all over the place. But some of that complexity comes just because like hardware is kind of hard, and hardware is very rigid. So you can't just kind of change things on the fly like you can with software. So yeah, those two are probably the most fun things that I've done. Next. Yeah.
Now that you zoomed out, like really seeing the circuit board type design in that, do you have like the idea of like a bus, like you would in a circuit design, where you could tie a bunch of things together into like, here's a common bus, then I'm gonna put it across different modules, or is that not really?
Yeah, again, this is like one of these, like, how much can I really like do in a certain amount of time? So it's more about like getting it made and getting some fun things, and then some of the nice things will come online. Yeah, definitely. Like pretty much all of the things that you see in circuit design will eventually make their way here. You don't want to. People have been, doing that for 100 years or whatever, and like they have. It's better to like rest on the what they have learned over their time.
Yeah, I mean,
for
I
different
could
things.
see someone that knows Eagle, KiCad, could sit down in this and go, oh, this makes sense. I can write code because I know how to design and all that stuff.
Yeah, I mean, so some of this is about, finding the right block. But again, a bunch of these code blocks here, there's just like a little bit of Python code inside of here. So, we're going to, probably some button is coming in here. And if the game state is something, we're going to go ahead and just like throw something up on the LCD screen. Yeah. Yes.
Do you have a, excuse me, do you have a concept of a virtual probe where you can look at when something goes over one of your connectors?
Yes, I have. Probably the way that I've thought about it at first is more just like if you could have something like one of these and you get like a live view and kind of these things will like light up as things go across. Is that maybe what you're asking? And maybe you can go in and hone in and like see what the last message was that went over this particular line was.
Yeah, I'm thinking if in programming, the messages aren't just bubbles, they're complex objects that get passed around.
Mm-hmm.
And it would be nice to say, I want to see what's being passed from this one to this one.
Mm-hmm. Mm-hmm. Again, and also because we have a REPL prompt at any of these, like at any time you have a program running, you can kind of just like peer inside and say, oh, you got some parameter here, like what is its state and like why is it doing whatever it's doing. Anyone else? Yes.
Are you at all familiar with the language lab view?
LabVIEW?
Yeah.
Yes, that's another one. I haven't really gotten to play with it very much. It seems very.
It's simple, but it's proprietary.
What's that?
It's proprietary, so I imagine.
Yes, proprietary is the one. Yeah. So like it kind of only plays with its own stuff. And so like
National Instruments.
I've seen it. I volunteered for First Robotics for a little while, and that's like one of the options to like do their programming. But like it just didn't seem worth it to play with it at all. But yes, that is another like boxes and lines type programming thing. I probably should look into a little bit more, but
I think this LabVIEW only works with National Instruments technology for the most part. It's
Correct.
really cool seeing this expand upon that and work with all kinds of other hardware as well. So it really brings that kind of like, I don't know, the plug-and-play nature down to like, I don't know, the masses.
Yeah, for sure. And like, so all of it's open source, and like I have a bunch of ESP32 modules, and there's nothing keeping you from ordering an ESP32 off of Amazon or Alibaba or whatever. And basically, you just chuck this on here. I guess if I show you, let's see if I can, whatever this thing is, we can go ahead and download a zip file. And now this guy gives you all of the code that is this. So you just like chuck this onto your ESP32 and you're on your way and you're running, and whatever it is that you programmed up here, this will be the RFID board thing. You got it and you just put it down. Anything else? Wonderful. Thank you guys so much for your input.